Okay, teardown time of a Candelabra light bulb from Philips. There's two bulbs here. There's one that's been damaged. The base has been knocked off, unfortunately. And there's a brand new replacement. I bought this one, I guess, a couple years ago. It's a 150 lumen bulb. And as always, there's progress. The replacement will be a 180 lumens. But I'm just going to put this one to service, and I'll take the broken one here and we'll tear it apart. So one thing you notice about LED light bulbs is the huge amount of engineering that goes on in these things. Obviously, the shell here just emulates the old incandescent candelabra style. But if you look close, you can clearly see a light pipe. And then they fully silvered the end with what looks like a paraboloid shape. So lots of engineering went on there, and interesting manufacturing to silver the end there like that on a plastic part. So interesting enough, another glass envelope. This time I didn't cut my finger. Ha! Still healing up there. Let's see, let's keep on going. So one of the nice things about the higher end Philips bulbs, there's the nice plastic coating here, and now there's a metal heatsink below. I'm sure that the heat management in such a small envelope is really quite a challenge. Okay, so I got the electronics taken out of the little shell that it was in. And here, of course, is the light pipe. It's actually even more complicated. There's actually little ridges on the bottom of it, so lots of optical engineering there. And the main emitter is just a single LED, and then a little plastic cap, and then a circuit board which holds the AC to DC converter. Interesting enough, these wires here are the color code that I most normally see when I tear down something from Europe. North America, it's usually black and white for the color designations, and here we see the ones I've only actually seen in products I've torn down that have come directly from Europe. Alright, let's take a closer look at this circuit board. So with the complexity of such a small assembly, you can see they had to go to essentially a three-dimensional type stack of components, and then they have to shrink wrap the parts so they don't short together. You can see this capacitor sitting on very long leads, and they've had to slip a little bit of insulating material onto it. An electrolytic capacitor basically sitting on top of what looks like, I would suspect, the EMI choke for conducted emissions. And if you flip it over the other side here, and I see that from a vendor at least I've seen before, I'll just pop in the insert of the picture of the IC, and then here's the data sheet, I think, of where the part's coming from. So no potting compound in this assembly, just a little tiny circuit board, absolutely packed with technology. So this is the new bulb, the 180 lumen replacement. You can see the bands on the screen, and those are actually aliases. It's called a beat frequency between the shutter and the bulb, which is producing probably a little bit of flicker.